Hello. Let me open the video. Also in a new window. Yeah. Okay. Hello, Sam.
Hi, Tony.
Hello. How are you?
I'm fine, thanks. You?
Pretty good, pretty good. Weather is great.
Yeah.
Cannot complain.
Yeah.
Yeah, I cannot complain though. Okay, we wait a few minutes so people can join and then we can start.
Okay.
Today we have a new fancy setup. Probably you guys are seeing me a bit more HD. Try to work on it. Make it a little better. Yeah, so Sam, what are you up to lately? What's going on?
Mostly sitting indoor, playing games. Call of
Right.
Duty Warzone.
Nice.
Yeah. You?
Well, the same actually. I started playing video games that I didn't do for a long time actually. And I played lately this game called Hellblade, Senua's Sacrifice. Super cool.
Nice. Cool.
Very, very nice. Beautiful graphics. But it's not made with Unity though.
No, it's a bummer.
Yeah, it's made with Unreal Engine 4. But
Yeah,
really, really well made, well made. It's more like a movie, you know.
Yeah.
And they also focus on mental health. The main protagonist has like problems, mental problems, so she hears voices and you hear in your headphones all these voices that gives you a hint or confuse you. It's really like a interesting experience. Highly recommend. By the way, this is not sponsored by by the guys of Ninja Theory. Just
But
chatting.
you can buy it right over here, right?
If you want, you can. Let's see. So I see some comments. Some people are starting to join. I would say probably we can start. Is already 03. So I guess we can start.
Nice.
Okay. So hello everyone. My name is Tony. And I'm a software engineer at SciTech IT Consulting, just like Sam. And today we are here with Sam. Hello, Sam.
Hi, Tony.
And you're watching the YouTube edition of SciTech Devjam. SciTech Devjam originally is a meetup group in Amsterdam where we gather to discuss different topics around programming, web technologies, and the latest trend in tech in general. And this is basically the YouTube version of it. Today we are here with Sam, and Sam is an experienced AR VR developer. He worked with Unity3D for many years, and he's gonna show us what he worked on lately at his last assignment at KLM, and also we're gonna build something interesting together. Spoiler alert: it's not just for video games, so we're gonna see something interesting. And yeah, so without further ado, I will give the mic to Sam. And just before starting, I would like to remind you guys, if you want to ask any question to Sam, please write it in the live feed and we will pick them up at the end of the presentation. Okay, so at this point I pass the mic to Sam. Good luck, Sam.
Thanks, Tony. Welcome, everyone. Well, my name is Sam Baas. Been using Unity3D professionally for more than 5 years now. Joined SciTech about 1.5 to 2 years ago. And I work mainly at KLM, like Tony mentioned, in a team that created VR trainings for KLM. We mainly used Unity3D there. So what I'm going to start with is show you the 3 points we're going to cover. First off, I'll start with explaining what is Unity3D. some of you might not know what it is, or maybe never heard of it. So I'll explain a bit what it is, then explain about the editor, some more details, and how it's interwoven with the programming part of Unity. And then I'll get into some programming in Unity. So on to the next slide. That's what is Unity. So I plucked this screenshot from the front page at unity.com. And well, the first thing you notice is that it doesn't only mention games. Some of you that might know it as a game engine, but it's actually more than that. Over the years, it broadened its scope a bit. And as you can see, next to the games tile, there's also automotive, transportation, manufacturing, films, animation, cinematics, architecture, engineering, construction. There, it's different areas that have adopted real-time 3D development platforms like Unity. And that's actually what they're calling themselves right now. You can read it over here. A real-time 3D development platform. So that's actually what Unity is. The game terminology is all around in the editor, so that's still there, but mainly it's a real-time 3D development platform, and I'll get into the real-time part later on when we jump into the editor. So what is a game engine? A real-time 3D development platform like Unity. It's a 3D rendering engine. It has support for complex lighting, shading, animations, physics, audio, and of course your own programming code to add interaction to it and make your application that is run in real time, where you can interact instead of just looking at a pretty picture. So my time at KLM would probably fit somewhere here, maybe automotive, transportation. I think personally there's still one lacking, that's training, because that might fall under these styles. On its own, training is very interesting for real-time 3D development. That takes me to the next slide. My time at KLM, what I made at KLM. I actually posted this video over here on LinkedIn that showcases some projects me and my team made over there at KLM Digital Studio. Now, Digital Studio is responsible for proactively innovating KLM as a company, and mainly focused on personnel. So what you see over here is all made in Unity. It's not rendered animation. It's all rendered real time in VR applications. So what you also already see over here is that this person is wearing a VR goggle, and it's an integrated device. So the hardware for this device is inside the glasses itself. It's like an Android-based system, like your phone. But this person is controlling a passenger bridge, or learning how to control a passenger bridge without needing any real passenger bridges or planes. He can practice, make mistakes, and actually feel like he's controlling a passenger bridge by only using an Android device.
Super cool. I see that they can also see the manuals.
Exactly, yeah. There's an example over here for this is cockpit training we made. That is the idea for this project was to reduce the cost of the simulator time, like pilots have to train in. Simulator time is pretty expensive, and what you see over here is a training that they can do sitting on their couch, because part of their training for pilots is, for instance, startup procedures. You don't need to do that or train that in a simulator. You can do that at home, sitting on your couch, wearing glasses like this. Especially now, that's really interesting during this pandemic. Of course, the demand for these kind of solutions is going up. So it's cool that we made this. At the start, you could see a pushback simulation on the Schiphol apron. So the person in this picture over here is actually controlling a pushback truck, a virtual pushback truck, doing virtual pushbacks with airplanes. So instead of you and me sitting there in a real plane and having a rookie do the pushback, they can actually train this in a simulated way using a standard desktop computer and VR goggles tethered to that. Now here we used a desktop solution because this application required more power and required a steering wheel and an input panel. So therefore we used a desktop solution. But for all these projects we used Unity. So this already shows you the cross-platform or multi-platform side of Unity.
Very interesting.
So I won't show the full video here. You can check it out on my LinkedIn because it might run a bit choppy here during the stream. But make sure you check it out. Really cool, awesome products by KLM Digital Studio and my awesome team. So this takes me to the next slide. The multi-platform part, which I already showed you a bit. Whatever you create in Unity3D, you can switch the target platform that you're going to build for to well, all these kinds of platforms you see over here. So where, for instance, you have created an iOS game, you can port it by just switching the platform to, let's say, WebGL if you want to turn it into a browser-based game. Or you want to turn your game into an Oculus VR experience with minimal changes to your code and interaction. You can switch the platform around, take all your assets, take all your programming, add a little bit of VR SDK to it, and you have converted your project to an Oculus VR project. Now there's more over here, and they're really adding more and more platforms really fast. So that's really cool. That's really a big pro of using Unity. Next slide takes us to a part I want to cover. So like the game, Tony, you played is made in Unreal. It's a really familiar name probably to a lot of people because a lot of games at the start you see made with Unreal. Unreal is an engine just like Unity. As you can see at their webpage, they're also calling themselves a real-time 3D creation tool now, not just a game engine anymore. A bit, it's like they're really looking at each other like, what are they doing? They look very similar. The biggest difference, I'd say, for both engines nowadays would be the difference in language. So for Unity, you would program your own code in C#, where Unreal uses C++. I'm a bit biased towards Unity because I used it way more than Unreal, but yeah, zooming out a little bit, in theory you would get a better performance using the Unreal engine because it uses a lower level programming language, C++. At the other side, Unity, C#, it's more similar to Java that has like a virtual machine. So in theory, you would get better performance using the Unreal Engine and C++ programming. In practice, you see a lot of games or applications made with Unreal that run really bad. The same goes for Unity, and you have photorealistic games and solutions made in both engines. Both of these splash screens over here are rendered in real time, so you can get really close to photorealism with both engines. So next slide. Some of the titles made with Unity. If you Google made with Unity, you find way more titles that might be familiar to you. I picked a few that shows the different range of things you can do with Unity. For example, City Skylines, which is a large city building real-time strategy game. Hearthstone, pretty familiar company, Blizzard, that also uses this engine for a mobile game. So Hearthstone is a mobile game, also cross-platform. You can also play it on desktop. Rust, which is an open world survival game, or Ghost of a Tale. Ghost of a Tale is a game that was being made by one guy. It looks really awesome. Be sure to check it out. I believe he's a DreamWorks animator that came from DreamWorks and started creating a game using Unity. So that shows you how easily you can change from being an animator to becoming a game developer, or easy. He's really good, as you can see in the picture. So those are some examples. Now let's start in getting into Unity. One of the first things you're going to do when you're going to download Unity is download the Unity Hub. Now the Unity Hub is something they added later. It's like a small intermediate tool that allows you to download different versions of Unity. and manage your projects. But it's a bit of a backwards compatibility sort of solution. Unreal does the same. So when you created a project in an older version of Unity, you can keep that version installed and install a new version next to that. And when you have to go back to that project, just use another version of Unity, which also automatically means you use an older version of the editor. It's a bit interwoven as well. So the editor and the Unity version are interwoven with each other. The minimum specs, be sure if you want to start trying out Unity that you have the minimum specs. It's not that demanding, but as you can imagine, when you want to make a AAA game with superb graphics, those specs go up the closer you get to a modern AAA game. So these minimum specs are actually, yeah, when you want to do some small proof of concept of games, but it goes up depending on your project, what you're going to do with it. Now, this is the tool I mentioned. So this is the Unity Hub, where you add a new version for Unity. Just add a new version. It's best to pick the latest official release when you start using Unity. It will ask you to install Microsoft Visual Studio. So I recommend using that, especially at the start, because it's like the vanilla kind of way to deal with Unity and the Unity programming. There's great support for C#, but of course you can use whatever text editor you like that has C# support in combination with Unity. But when you start using Unity, I recommend Microsoft Visual Studio. Now here you can see I checked the Android build support, so it's optionally the multi-platform part. So whatever platform you want to add, you add a separate installation for that using the Unity Hub as well. As you can see, the file size gets big pretty fast, so you might not want to install everything. And for now, I checked Android build support just because I want to build something for my phone, for instance. So it will take a while to install, and when it's done, we'll get to the part where we start creating our own project. So now it's going to be live. This is me live interacting with the Unity Hub. So I'm going to start a new project, just fresh. It will ask you to pick a template. Now the 3D one is the vanilla template, the starting template for a Unity project. There are some more like 2D, then your workspace is set up for creating a 2D application. In the basics, it's the same engine, so it doesn't matter if you pick 2D, 3D, or other flavors. You can convert it later to other setups as well if you would like that. I'm going to call this Devjam Live. At that location, I'm going to create it. It takes a while before the project is set up. When that's going on, it creates a folder. At the location I targeted, I'm going to quickly show you a bit on what is created over here. The most important part is the assets folder. So that's where you put all your stuff, your 3D models, your sounds, ordered in folders. And the project settings, that has all the settings for your project in text-based asset files. Next to that, library, logs, packages, all generated stuff. So if you want to put this on Git, for instance, you can ignore all that stuff because it's generated anyway. So the most important part to keep would be assets and project settings. Now Unity is done setting up my first project. So this is the editor, the Unity editor. As you can see, I got a dark skin. That's one of the perks you get for an official license. When you start using the free version of the license for Unity, you get a lighter skin. So that, and next to that starting logo of Unity for your application you build, that would be the difference between the free version and the licensed version. So that's why I have a dark skin in case you start Unity and it is a light skin. That's the reason. So what are we looking at? So if you're not familiar with 3D design, it usually comes with a 3D scene or 3D world, which I'm looking at right over here in my scene panel. Using W, A, and D buttons, I can fly around my scene and look at it from all kinds of different angles. At the left side, at the hierarchy panel, I can see all the objects that are in my scene, and I can select them. At the right side, let me drag down small window. Yeah. At the right side, I can see the components that are added to the object. So now a fresh starting scene only has two objects, like the minimum stuff you would need for a starting scene. That is a camera. Now the camera is really important because that's the viewing point that we're going to look at our application. So the game view right over here is showing me what the camera is seeing. Right now it's an empty world, so I can't see anything. But if I were to add, like, let's say 3D object, a quad, put it at 0, 0, 0, which would be the center location of my world. Let me rotate this around. There we go. Now I got like a small floor in my world, and let's add a sphere on top of that. Now I'm adding a primitive object, so Unity comes with some primitive objects off the shelf. One of them is of course a sphere, a cube, what more do you, a capsule, a quad like the floor I added, or a plane which has more geometry to it. So as you can see, my camera is now seeing the sphere I added right over here. And when I move it around, move the camera around, you can see that my game view is showing in real time what that would mean in my application. The same goes for moving my object around. You can see the changes in real time. So on the right side, on the inspector, I can see the stuff that is added to my object I selected. So these are the components that are added to this object. Now in its most minimum shape, a game object in Unity, so that the objects that are added to my scene is an empty object. An empty object only has a transform. And a transform is like the minimum thing we would need for an object to be present in a 3D world or in a 3D space. And that's like having a position. So where is it in my world? Where 0, 0, 0 is the center of the world. Rotation is the rotation of my object. The scale, of course, the scale of my object. And selecting the sphere, you can actually see that happening in real time. Now, if I compare an empty object to a sphere, you can see that they both have a transform. So in the basics, they both are a transform, an empty transform with components added on top of that. So in this case, I have a mesh render, a mesh filter, and a sphere collider added to it. Now, I wouldn't need this sphere collider. That's actually for the physics engine, which I'll get to later. So minimally, I would need a mesh filter, which says what kind of mesh, what kind of 3D shape is being drawn here. So if I change this around, it actually changes shape. The mesh renderer, that's the component that's actually actively rendering this object. That has a lot of properties to it. And one of them is the material that geometry is going to have. Now, with basic objects like this, you would start with a default material that is simply white, and so you have something to look at, but you can add your own materials to that. Now, one of the more interesting parts of Unity is the prefab system. So I got my sphere over here, but let's say I add another sphere on top of this. Scale it up a little bit, and add another sphere on top of that. I'm going to build like a simple snowman. In the hierarchy over here, you can see my objects. You can add objects to other objects by simply dragging them onto them. And what this will do, what a 3D hierarchy is whenever a parent object like this sphere over here has children in it, and I translate this or move it around, the children move with it. Same goes for scaling, rotating. So now I've created my own object over here. One of the cool things of the Unity prefab system is that whenever I drag a small piece of hierarchy here in my assets folder, it will create a prefab asset. Now I've created my a small piece of hierarchy that an object that has its own piece of hierarchy. So you can see it turned blue right over here. That's because it's a prefab now. And when I go into this object, it's only focused on this object. So I'm inside this object now. Whatever change I make to this object, and I go back to my scene, changes for this object in every place this prefab is added. So now I only got one, but if I duplicate this, put it somewhere else, because my world has a lot of snowmen in it. Now if I were to change this prefab, change its head again, something smaller, go back, you can see it changes everywhere. You don't have to go in, you can also make a change right over here, and Unity will detect it's an override of the prefab setting. Right over here on the right side you can see a small blue indicator that says, hey, this is an override. But if I want to apply this, I can right click and apply it to the prefab, and you can see it happens all over the place where the snowman is sitting. Let me add back the colliders, because I'm going to need those. Sphere collider. I'm quickly going to show you the physics engine. That as well, sphere collider, and that's a really cool prefab component to use. So on the right side here you got the components, like all the default Unity components, and I'm gonna add another component. It's called a rigid body. What a rigid body is, it tells Unity to use this object in the physics simulation. So Unity has a physics engine. And whenever I want to run this and see what the physics engine is doing, I have to start my game. Now I haven't even shown you how to start and play my game yet, so I'm going to show you that. I'm going to save my scene, and I'm going to press this play button here on the top. And what you will see is that my snowman dropped down. I can move it around a little bit so it starts tumbling. Now, because the play arrow is pressed in, it's blue, it says my game is running. So whatever I'm doing right now, I'm actually in real time interacting with my game. So like picking up the snowman and dropping it, or maybe even duplicating it. They pop out because they spawn in each other, so the physics engine pushes them out. As you can see, I can interact with this in real time. And change values right over here, move things or scale. One important thing when you start with Unity is to learn is that whatever you do during play mode is not saved. This is running our game, but it's not saved. So whenever I'm building a giant map, or I don't know, some giant world with all kinds of assets in it, and I forgot that I'm in play mode, whenever I leave play mode, everything is gone and reset to the default starting setting. So always make sure that you're not doing changes you want to keep during play mode.
Good to know.
Yeah. So let me see. So this is the prefab system. It's really important part to know and to learn. You can actually do nested prefab. So let's say I want to create a prefab over here of the head. You can do that as well. So you can nest prefabs as much as you want. It becomes a bit complex at some point. So especially at the start, I suggest not doing that too much. So that's the physics engine part. Now the rigid body, one thing to mention is the mass right over here. That's in kilograms. It's a bit arbitrary because the units are a bit arbitrary, but mainly because of the gravity default gravity setup. The mass is 1 kilogram. Units are in meters. So when I look at the settings right over here, project settings, physics, you can actually see the gravity setting over the y-axis set to a minus 9.81 number.
Nice.
Now, Tony, do you recognize this?
Yeah.
Tell you something?
Yeah, it's exactly the gravity, the real gravity here on Earth, meter per second.
Exactly. Yeah. So our snowman world would be on Earth right now, and on Mars it would be a different number, of course.
American people from USA are not very happy with the metric system, I guess.
No, I guess, but in that case they can define units as something else if they would like that. You're not tied to that. So like the units over here, if you if you're building on a game that needs more precision, you can say, okay, and my application 1 unit is going to be 1 millimeter, for instance. In larger worlds, you want to use a unit for a larger value, but because of the default settings, it's good to start with mass being 1 kilogram and 1 unit being 1 meter.
Okay.
So there's that. Now, of course, these are all default Unity components that are, there are a lot, and it's way too much to get into, especially because I want to get to the programming part. That would be most interesting for most viewers. So I'm going to add a component, and I'm not going to add default component, but I'm going to scroll down to new script and add my new script, move snowman, create and add. Now this creates a script in my assets folder right over here. Now normally the default Unity way would be to have a scripts folder, but it's and drag that in there. I have a prefabs folder for my prefabs, just to keep it a bit tidy. Tidy up. So my snowman and my snowman head over here. So I got my script, and when you set up Visual Studio as your default development environment, you can double-click the script to edit it. You can also click the object, like the snowman. Hang on, Visual Studio is starting. I can also click the object, right-click the script, edit the script. And you can see the blue parts right over here that says I changed my my prefab, so I'm going to apply this to all the prefabs. This as well. So all my snowmen have a rigid body, physics, and I'm going to get into my own script I just created. Now it's not empty. You usually start with a default script like this when you create a script in Unity. One of them standard methods you have is the start function, start method. This one is really important. This is actually called once when the first time this object is rendered or has one tick of the game loop. The first tick of the game loop, this is executed once. So this is great for initialization stuff, or getting references to different components like the rigid body I just added, if I want to tinker with that. And next to that, it's the update function. Now that's a really important one in Unity. That's our game loop. That's our main game loop, and that game loop is tied to the frame rate of our application. So whenever the camera, my 3D camera over here, is rendering 1 frame of our real-time application, all the objects are executing the update function 1 time. So this is great for continuous motion stuff that is going on. Now I'm gonna show you an example of that. Like this transform references my transform, so the thing that has my position, rotation, etc. There's a function, it's called translate, and I can add a number to that. Let's say that's. And for people new to C#, I added an F over here because that tells that this number is actually a float. Otherwise, it would have been a double. But Unity uses floats, so you have to do the suffix with an F. So when I did this, I saved my script. Unity will automatically import this whenever I get back. So let's go over here and press play and see what happens. You can actually see it bouncing up and down right now, and that's because I'm doing movements over the y-axis. And apart from that, I still got my physics object in there. So I'm gonna get out of play mode. I'm gonna remove. I'm gonna remove the physics object, because I just want to control this using my script. I don't want to use the physics engine for this specific snowman. So I'm gonna translate it not over the y-axis, I'm gonna translate it over the x-axis. There we go. This is x, y, z. I'm gonna press play. There he goes. He's not falling down, continuously moving and translating into that direction. Now this is hard-coded stuff, and one of the pros of using a real-time 3D engine like Unity is that you can tweak variables in real time, and I'm going to show you that. So let's add a float value over here. That is my snowman move speed. Yep, it's hard. Just going to add a default value. But by adding a serialized field on top of that, this variable is actually going to be serialized and exposed in the editor. I'm going to use this value over here instead of my x value. Save it. Go back to Unity. As you can see, it actually already created a field right over here. That is my snowman move speed. And because I use camel case, Unity automatically detects that those should be different words, so it's actually pretty readable right over here. And now when I press play, it'll move really, really fast. It's because it's 0.1, but if I move this around, I can turn it around by using minus value. But I can tweak this in real time. Now it's really, really fast, and that's because I got a pretty fast laptop. One of the things you should know is the update loop, the frame rate differs per system. So if you've got a really strong computer or the latest graphic card, then your application actually will run faster. So one of the things to take into account, this is actually going to be a speed that should be similar on different kinds of computers and systems. And you're going to have to multiply it with time.delta time. Now the delta time part is the completion time in seconds since the last frame. So as you can imagine, that time or that value will be smaller on faster machines. So that way, when I multiply using that value, it will actually be the same speed on different systems. That's really important if you're using the update function. So of course it's really way more slower now.
Way slower, in fact.
Yeah. Oh. I can tweak it and move it up. Now on.
Can I ask you a question, Sam?
Yeah, sure.
Is it possible to animate this way also the camera?
Yes, of course. Yeah.
Okay.
That's a cool thing of the component system, and like my snowman, camera also has the same transform to it. So now I created the component.
Because sometimes, you know, I see this video made with Unity. Francesco, one of our colleagues, suggested me to watch this very interesting 3D video made with Unity, and it had all kind of cinematic moves with the camera. It looked very real. So I imagine that it was possible.
Yes. Yes, you do have an animator in Unity, so you can choose to actually animate the camera, a bit like After Effects or Premiere, where you add keys to a timeline and just move its position on a certain time, and it would automatically move towards that position over time. But, that's the animated part. That would be maybe something to go into another time. That's more like the visual side of Unity. Don't want to get into that too much. Just want to get into the programming part. So that way, maybe to answer your question, using the programming part, because I moved my snowman and made a script for that targeted my transform and does a movement over time. I can add the same component, which I just now did, to my camera object, because it also has a transform. So if I press play again, you will see that my camera actually starts to pan over time.
Oh, wow. Cool.
And now I got the same speed set as my snowman. That's why it looks like it's standing still, but if we were to turn this around now...
Ah, nice.
It's going to move over time.
And that's an easy way to make a pan.
Yeah.
Nice, thanks.
Cool.
Sorry for interrupting.
No problem. So this translation, of course, you have rotate as well, which is a rotation where you can apply a rotation directly. There's a lot of stuff you can do. You're not only tied to floats here, of course. You got more advanced stuff like serialized field factor 3, position offset 0 default value. Now you can see I also get a position offset which generates fields that are nice for this particular variable. Now the cool thing is when I create scripts like this or components like this, at some point you have a script you can give to persons that are not really into programming but still are able to do a lot of work on an application that you're building. So my snowman world, was good to show you a bit of the basics of the Unity hierarchy, the different views, the scene view where I can float around, the game view, which is my game, the inspector, having all our components. But I wanted to prepare a small project for you guys that shows you a bit more of something that you can create pretty fast. I'm going to get to that scene. I already have an instance open here, a different instance of Unity. So you can have multiple instances open of different projects or even different versions of different projects. And I'm going to show you something that we're going to build. This example only uses primitives. So everything you see here you can recreate by only using primitive objects. I wanted to create something that's somewhere between a game and maybe some scientific stuff, somewhere in the middle. I'm not sure what most of you are interested in, but this can give you some knowledge for both paths. And what you're looking at now is the Cytec Roomba.
It's a Cytec Roomba, yeah, that's what I was saying. Good
you recognize it. Only with primitives. How awesome is that?
Yeah.
So this object, my prefab over here, just like our snowman, is a collection of objects which are all primitives. So the body is a cylinder. I scaled down a bit over the y-axis. The wheels are cylinders. I added a little sphere on top of the wheels to show the rotation, which I'll get to later on. I added the bumper, which is also a cylinder. I can show you because it just intersects the other one. It's the bumper for a Roomba. Now the cool thing is about this project is that it shows you a handy thing you can do for scientific projects, but also for game projects, and that's how the Unity Physics Engine connections work. And the prefab system, using nested prefabs. So I created a robot, and what I wanted to do was create a scene that would allow me to test out different kinds of theories or proof of concepts for a different kind of AI for my Roomba. I have a Roomba, it's like the Dumber model that drives around and has to bump into furniture and then knows, oh, there's something there. He backs off a little bit, makes a small turn and starts trying to find a different path around the object. So I wanted to start with that, recreate that in Unity and create like maybe a copy of reality or a small copy of reality to have a small simulation and then start iterating or adding scripts to that to test out different kinds of sensors or different kinds of artificial intelligence. I have to be careful with artificial intelligence, but calling it that because it's too dumb for that, but you get the point.
Yeah.
So I created a robot using cylinders, and I added wheels to that. So starting out with the wheel, I only created one wheel because I knew on both sides I want the same wheel, and that's cool with the nested prefabs part. So I added a wheel prefab, which I get into. It's only a cylinder and a sphere. We have the visual part for the rotation. Added a component to that, a wheel engine. That's my own script, which will open up. Capsule collider, I want some collision. The reason I picked a capsule collider, I have to show a slide for that. There we go. The reason I picked the capsule collider because it's really fast. A fast collider. So one thing you have to know, dealing with the physics engine in Unity, it's a physics engine that's made for speed, not for accuracy. So be careful with too scientific stuff, creating scientific calculations, for instance, or the structural integrity of a building. Don't use the Unity physics engine. But it's made for speed, so that's why you have to be careful with the colliders. So the fastest collider would be a sphere on the left. Then the second one is a capsule collider, and then next to that is the cube that you can use as a collider. And of course, next to that is way more complex shapes, your own meshes for testing collisions in the physics engine. So let me go back. Not the snow. I'm going to close the snowman scene because otherwise I'm going to open it up every time. There we go. So here's my wheel. I created the wheel. I added my own script. It's called the wheel engine. This is how it looks. So we got our start function. I actually used the awake here. The awake is another standard method that actually executes in front of the start function. I add a start function over here as well. So this is very handy if you're dealing with your own components. So in this case, my wheel engine can execute this earlier than the start function because it only relates to my own components. So in this case, I want a reference to my joint, which I'll tell you more about in a bit. A physics joint and a joint motor. So that's the hinge joint I added on top of my rigid body component over here. Now, it looks a bit advanced, it has a lot of values, but the main thing to know about this is it just shows the physics engine, or tells the physics engine what other rigid body this rigid body is going to be tied to, so attached to, and what constraints it has in sense of rotation. So in this case, I only want to rotate over the y-axis, and I have angular limits that are 360 degrees around. So if I want to lock a wheel in 180 degrees, I can do that, but I want a freely spinning wheel. So that's why I created a free rotation of 360 degrees around the y-axis. So that's the component I wanted to target, because one thing this component has is a motor. Now, a motor is really what it is. It's a motor that allows me to add a certain velocity, continuous velocity to this wheel, so it keeps on spinning whenever I change that value. Oh, sorry. Here. So that's my wheel engine. But I want to do this from outside my wheel engine, because I want my computer that is added to my Roomba to control this wheel engine. So that's why I made a public method over here. It's called throttle, and it's gonna change the target velocity of my motor. And you have to reapply the motor to the joint whenever you changed it, just as an optimization for the physics engine. You only want to change a value whenever you really want to, so that's why you have to apply the component again. Now that's the wheel part. So that allowed me to position the wheel in my robot, and I added a copy of the same prefab on the other side, because it's exactly the same. It's actually exactly the same axis that it's constrained to. It's only rotated around 180 degrees. And I added another script on top of my main body of my Roomba. That is my computer, the computer of my Roomba, my Cytec robot. I'm going to open up that script, tell you what's going on there. So the computer, I created two references, so these aren't only for variables. You can also add references to other objects of a certain type. So this is my own type. It's not a float, it's a wheel engine. It's the name of my class. I called one left wheel engine, right wheel engine, because I only need two wheels on my two wheels on my computer. And I added some functions over here. Then I'm going to target using other scripts, using my AI script or keyboard inputs. One of them is idle. I'm just going to put both of my wheels on idle. My forward, I'm gonna throttle my wheels forward, so it's gonna move forward, etc., etc., etc. Turn left, turn right.
So basically,
Now
you're
I'm gonna show
defining
you-
the possible actions for the robot.
Exactly.
They would be called from someone else.
Exactly. Yeah. So I added two extra methods on top of this. One of them is keyboard control. It's a script I made that's going to control those values in the computer directly using hard-coded keyboard inputs. So the same for this component. At the start function, I'm going to get a component reference to my computer, which has the methods to turn left, turn right, and add key actions to that. So I'm going to show you how that looks in my scene. Let's see this one. Gonna press play. So we're making. So there we go. I'm looking from a top-down angle because I position my camera there. Whenever I key press to the right, my robot's gonna turn forward. It's gonna move forward. Turn to the left. It uses a bit like tank-like controls, just like the real Roomba.
And just to be clear, the little noise in the background is not the Roomba, but is your computer.
Do you have noise?
No, we don't have noise. It's a joke.
Okay.
It's pretty silent. My computer will be already on the moon, probably.
Nice. I did have 3 beeps coming from my motherboard today, so maybe I got a heating problem. Because I do hear my fan spinning a lot in Unity. Maybe I have to clean it.
Yeah.
So that's my keyboard control.
So basically now you chose the keyboard controller. And
yeah, that's one of the easiest things to test out your physics object you made, or the fixing of the wheels to the body, just using some default keyboard inputs. Have it drive around. Okay, this is exactly what I want. I actually added a small wheel in the front of the Roomba, which is a freely spinning ball joint. I used a configurable joint for that. It looks way more complex, but basically I tell it what kind of constraints this is going to have. Aside from the hinge joint, this allows free motion. So I actually locked the motion axis right over here because it just has to keep its relative place, but have free motion over the X, Y, and Z axis. That's why it just freely spins around and follows my Roomba whenever my wheels throttle it around. Now, I'm not sure if you noticed, but it actually uses the physics engine now again. So whenever I lift it up, runtime, let me get my body, it will fall down. There we go. And you see it's not tipping backwards only when I throttle. That's because I added a little weight or mass to the front wheel right over here. So mass. So it has more weight in the front, so it won't tip over to the rear. Another way to do that would be to get the rigid body from a script and change its center of mass through script. You could do it as well, but because I already have a rigid body in the front, I just made it more heavy to add more weight to the front.
So I can already see that with all these features and possibilities that you have, it's a very interesting tool to make some kind of simulations. In this case, for a Roomba. So for example, if you have a model of your house, you can test where it can go, or you can try to run some kind of AI or machine learning on top of it and see what it can learn to do, if it can learn where there is the carpet, where there are the stairs, and so on.
Exactly. Yeah, that would be the scientific part of using Unity, stuff like this, simulations, you can do that. And the AI part, the script I added, I'm going to show you right now, isn't necessarily AI, but you can actually hook Unity up to actual machine learning tools. They actually have an open source Git repository for that from Unity Technologies that actually use machine learning agents. So whatever I'm going to create over here, whatever AI script I'm going to test, you can actually create a learning system and hook it up to Unity and have Unity act like the visual front of the machine learning research you're doing. So that takes me to my own AI script. I'm going to open it up, enable it as by default controller. So I got my automatic AI control. I had a small state machine, if you want to call it that, at the top. So I want my automatic AI to be able to idle, to go forward, to reverse, to turn left, turn right, and I want this to happen automatically. So whenever I start, I get the reference to the computer again. I start in the forward state. So that's the default value I set over here. And these values are enums. This is like a readable numbers. It's 0, 1, 2, 3, but then in a readable way. Those are enums. So in the update function, I just catch whatever state my robot is in and do the appropriate response for that tick in that state. So in idle, I'm going to call the computer idle again. In my forward state, I'm just going to keep on calling going forward. And you can see I made a bump sequence method. Now that's a really cool one, because that's actually part that I tried to recreate that my real Roomba has. It has a bumper sensor in the front. So that's the cylinder I added to my hierarchy. It's also a physics object, which allows me to collide with the boxes, the green boxes in my room I made over here. And I added my own script. It's called a pressure sensor. Not sure if it's called that like that in real life. I'm sure it would be named something like that. A pressure sensor, and whenever I do a collision, so I'm using the onCollision enter function, the standard Unity method, just like start update. There's onCollision enter. I'm using the same this function for that. Whenever I do a collision, I don't mind with what I'm colliding. I'm gonna invoke an event, a Unity event. That's a serialized field I added on top here. Just like a float or the factor 3 I showed you, or my own components. That is a variable that will be exposed in the Unity editor, but in a very interesting way. So I'm going to clear it for now. See, I got my robot automatic. Normally, when I have an empty event, it's like this. So whenever bump into something happens, it's gonna execute something on an object. So now I would be able to drag in my computer. That's on my Cytec robot. Dragging it in, and then I can choose whatever method is going to be executed whenever I bumped into something. And I'm going to call my bump sequence on my automatic AI control. So now, in theory, when I get a collision with my bumper, I'm going to invoke the event. Because the event is evoked, my Cytec robot, my automatic AI control behavior, my component, is going to execute the bump sequence. I'm going to go back to my bump sequence. So this is going to stop all coroutines. Now, coroutines are Unity's way to create like a parallel process to the Unity game loop. So whenever the bump sequence is started using a start coroutine, it's going to run this process just apart from the game loop, and it allows me to actually wait a few seconds, then do another change my state to another state, wait a few seconds again, then do another state. So this is a really simple way for me to saying, okay, I'm going to start after I bumped in to reverse. I'm going to back off with my Roomba. I'm going to wait a few seconds. In this case, it's not going to be full seconds. It's going to be like half a second. Then I'm going to turn right. I'm going to wait a bit, and then I'm going to move forward. So because I turn right, the state changed to turn right. It's going to continuously keep turning right whenever I reverse, and whenever this timer has ended, it's going to change to the next step. So I'm going to start and show you how that's going to look.
That's very interesting. It really reminds a state machine that is bind together with these events and the coroutines.
Yeah, Exactly. Yeah.
That it's basically a state machine reacting to sensor events.
Exactly. Yeah. And I am setting it up this way because I know in real life I'm not a guy who's into robotics. I would love to be, but I'm not really into that yet. But I just want to test out some theories. That's why I chose a way to set it up like it would work in real life, trying to recreate the objects that you would have in real life, and maybe allow me to add more sensors when I find out this is not going to work. I need a bumper at the back as well, or whatever. Maybe I need some kind of camera in front that does ray tracing, or something similar to LiDAR. I don't know.
Mm-hmm.
But I try to recreate, the reality a bit. So I'm gonna press play, see what happens with my amazing AI. There he goes. I'm gonna get into the scene view to get a closer look. Yeah, he bumped in. Okay, he's turning to the right. It's not much, but because I expose my variables here in the editor, I can increase the seconds I'm turning right after a bump. More. Yeah. That's better. So that's really the real-time part. Now it's moving there. Oh, there goes my cube. Gonna move this.
It's gone into the abyss.
Yeah. Fell through my floor. Okay, bumps. Now it takes longer to make it turn to the right. And because this is in real time, I can tweak values in real time. I immediately learned, okay, this value is too little. It needs more. And it's actually already, pretty much starting to do something I had in mind. It's trying to move around objects. It's trying to move around the room.
That's remarkably similar to the real Roomba behavior. You know, the most basic ones.
Yeah. They're actually still pretty dumb, but you get pretty good results with very simple AI.
Yeah, very simple algorithm, just going around and following the borders.
Yeah. Of course, the real one has something like memory. You could program that yourself, of course, like remembering where you bumped into something, maybe creating a zone there and have some kind of memory that you can't move there anymore. Or maybe stop earlier, so you don't have to run into it again when you pass it later on. Now the cool thing is, because this is a simulation, I now have one floor, one situation, and one Roomba. But if I just select my robot, my floor, let's select everything except my camera and my directional light. I'm doing this in runtime, so it's gonna disappear anyway. But I think I already duplicated stuff. Good. Duplicating it. There we go. Now I have two situations. Two Roombas driving around.
Oh wow. Mm-hmm.
Now I could tweak one of these values to be faster and let them compete with each other. Of course you can speed up the time scale, so we get time setting over here, stuff like this. All these settings you can access from your own components as well. Because let's say I'm going to increase the time scale. Now a multiplier of 10 would increase the speed by 10.
It's very interesting, and I noticed that Unity has a page dedicated completely to machine learning. So you can download pre-trained agents, if I read correctly, the machine learning agents, and there are also some competitions. So I think it's would be really interesting to see a possible continuation or a part 2 of this with some machine learning, maybe. I don't know, just saying.
That would be really cool. Yeah. That would actually be the next cool step, using stuff like this to actually automatically let it train and become smarter by having some kind of natural selection going on. So the winner.
They're running the training yourself with different cycles. It's not going.
Yeah.
Or just download the pre-trained agents if it's available. I'm not sure.
Exactly. Yeah. I'm not sure if they have Roomba pre-trained engines yet, but the cool part, yeah, then it would be cool to create the training algorithm ourselves.
Yep.
That would be awesome. Yeah. And maybe I can, next, I'm not sure, what time do we have? How long?
Well, we are already out of the time bound. It was 1 hour, but it was very interesting. So
Nice, yeah. Cool.
Okay.
So yeah, there's a large visual part to Unity as well. So I usually see I already added some fancier material on the floor. That might be something interesting to cover as well in a next Devjam.
Yeah, those are shaders, right?
Let me know in the comments. Sorry?
Those are shaders.
Exactly. Yeah, the shading, the lighting, materials. It's a world on its own. There's way too much stuff to cover in just this time.
Definitely.
Just like the modeling, I deliberately created an example product you can recreate by just using the primitive object. But of course, there's a whole modeling part to Unity as well. Unity itself is not a modeling tool. You would need third-party tools for that. But that's a world on its own. It's something for a different time. But if people are interested in that, let us know in the comments, I'd say. And we'll be sure to follow up on that.
Yeah, definitely. Okay. So here we are together again. Put back my hat.
There's one thing I wanted to add. Now we're almost out of time, or are out of time. Sorry, Tony. But
Sure.
Right now, if you go to learn.unity.com, you're interested in Unity. There are actually some free trainings available now. Because of the pandemic, they made certain premium trainings available for free. So be sure to check those out. Those are done really well. They really made big steps to welcome new Unity developers. So the trainings there are really cool, and be sure to check that out.
Yeah, I think they have free trainings till end of July, if I remember correctly.
Oh, nice. Yeah.
Something like that. Okay.
Cool.
Well, thank you very much, Sam. It was very, very interesting. And
Thank you.
At this point, I would like to check if we have any questions. I have some questions myself, by the way. Sorry. So there is one question from Manuel. So Manuel says, Sam, what resources do you recommend to learn Unity? I tried some free courses, but I'm sure there are better resources than the one I checked.
Yeah, I think I just answered that. I'd say the premium courses are really good. I showed you the Unity Hub. They also have, when you download Unity, some starting examples there as well. They also changed that. So if you see the hub right over here, there's a learning tab. This has some starting projects. So you start with a pre-made project, but then you're gonna do changes to those projects. So if you would start this karting micro game, you would start with a pre-made karting game, but have explanations in the editor on top of the parts, and follow steps to add, in this example, add some heads to a guy karting around.
A good head start, or a scaffolding, if you like.
Cool.
Nice. Let's see.
Is that the only question?
Let's see if we have more questions. Excellent job. Thank you, Ram. Yeah, seems we don't have any more question. My question for you was, I think a big part in Unity is also around all the 3D models that you can use or you can build yourself. Would you recommend any tool for this?
Yes, definitely. I would recommend Blender 3D. Mainly because it's open source. It's written in Python, so you can have total control of your 3D application. It's open source. It's free. It's a Dutch project. It's made in Amsterdam, so that's really cool.
Oh.
So if it crashes on you, you can drive to Amsterdam and ask them what happened.
Oh, okay. I didn't know that.
I used Autodesk 3ds Max a lot, and I used some Maya in the past, which is also from Autodesk, which are pretty expensive 3D modeling programs. but Blender 3D has gotten so good over the years that it's my first choice when it comes to 3D modeling, and it works really well in combination with Unity. Especially the hierarchy parts, you can just transfer it from Blender to Unity, and it's in sync.
Very, very nice. Okay, I don't have any more questions. Check one more time the feed. Looks like we don't. Okay, well, thank you very much, Sam. It was very, very interesting. And one thing for everyone. So we have a form, a Google form in the link description. You can head there and leave some feedback for us so we can improve this format. But also, let us know if you want to see a part 2 of this series, if you like, with Unity. I don't know, if you want to see how the Roomba works on Mars, for example, or how it would work with some machine learning models with it. So there is a Google form. Would be really appreciated if you can head there and leave some comments. And yeah, this is it. Thank you again, Sam, for this very nice presentation, and thank you everyone for joining us today. And at this point, I wish you a nice evening. And the next appointment with Devjam is going to be probably in around 2 weeks. And we are going to talk about Scala and functional programming. So that's also not to miss. And nice. Yeah, said that, I wish everyone a nice evening.
Nice evening. Bye.
Bye.